Okay, good afternoon to all the students. So, in the today lecture, we're going to see thermodynamic properties. Thermodynamic properties, which is the basic fundamentals to understand about the thermodynamics or the thermal properties. Okay, so first I share a short video. So after that, I will explain what happened in the video. Okay. This video belongs to the thermal property of a material. Okay, what the different substance or matters is having the thermal properties. This video is describe that. Yes, I definitely share the link for the video.
Condition is
Okay,
called
so first
properties,
we
which means that
go
if
to
we
that.
want to describe the physical condition of a system, we have to mention something like pressure, temperature, volume, energy and density. If you are saying that the pressure of the system is P1 and temperature of the system is T1 and volume is V1, like that we can physically imagine what will be the condition. So for example, consider a system in which the pressure is 1 kg per centimeter square and the temperature is 100 degrees Celsius. And another when the properties when another value, that is pressure, is equal to 2 kg per centimeter square and temperature is 200 degrees Celsius. So when these properties are having some definite value, it is called a state of a system. So we will be explaining this with an example. Is having some amount of gas inside, that molecules are moving, so we can say that it is having some amount of pressure. Welcome to Simplified Engineering. This is video lecture number 7 and the topic is thermodynamic properties and state. System which describes its physical condition is called properties, which means that if you want to describe something like pressure, temperature, volume, energy and density. If you are saying that the pressure of the system is P1 and temperature of the system is T1 and volume is V1, like that we can physically imagine what will be the condition. So for example, consider a system in which the pressure is 1 kg per centimeter square and the temperature is 100 degrees Celsius. And another when the properties when another value, that is pressure, is equal to 2 kg per centimeter square and temperature is 200 degrees Celsius. So when these properties are having some definite value, it is called a state of a system. So we will be explaining this with an example. Consider a cube having some volume and it is having some amount of gas inside, that molecules are moving, so we can say that it is having some amount of pressure P1 and the temperature we can measure it using a thermometer and the pressure by using a pressure gauge, and we can say that it is having a pressure P1 and temperature T1 and its volume is V1 and the total energy of the system is E1. So these are the properties, and we can, when we are specifying some specific value to all these properties, it become a state of the system. Consider another state, its pressure is P1 and the volume is V1. We will run, and the temperature we can make a cube having some volume and it is having some amount of gas inside, that molecules are moving. So we can say that it is having some amount of pressure P1, and the temperature we can measure it using a thermometer and the pressure by using a pressure gauge, and we can say that it is having a pressure P1 and temperature T1 and its volume is V1 and the total energy of the system is E1. So these are the properties, and we can, when we are specifying some specific value to all these properties, it become a state of the system. Consider another system in which it is smaller in size, it is also a cube which contains gas. So it is having some another pressure P2 and temperature T2 and volume V2 and E2. So the first figure shows some state and the second figure shows some other state, because the properties values are different. Okay, now we can represent the state of a system in graph by using properties. Now I am going to draw the one of the properties graph, that is on x-axis and y-axis will be the, on x-axis we will be writing volume and on y-axis we will be writing pressure. This graph is called PV diagram. So the state is P1 V1, which means that at that state its pressure is P1 and the volume is V1. We will write the second one, it is having a pressure P2 and V2, means that when the pressure is P2 and V2, the second dot is the state. Okay, to specify the state we need the properties. Now we can draw some other graph also, like PT, VT diagram, etc. So consider another graph which is TV diagram, which means that we need to, in order to say specifically mention the state, we need the temperature and volume value. When the temperature is T1 and the volume is V1, the state will be this one, and when the temperature is T2 and volume is V2, the state will be this. Okay, now I am going to different types of properties. Properties are mainly classified into two: intensive properties and extensive properties. Intensive properties, as the name mentioned, it is the property values are independent of mass in the system. What is mean by that? If you are taking some amount of mass from the system, the property value remains same. Examples are pressure and temperature. I will explain this intensive property with an example. Consider a metallic cube which is heated and it is at 800 degrees Celsius and the mass is 50 kilogram. Now what I am going to do, I am cutting the mass into two pieces. So what will happen? The mass will be split into 25 kg and 25 kg each. So mass is reduced to half. So what will happen to temperature? Temperature will be same. Why? Because if you are cutting an 800 degrees Celsius metallic body, the both will have the same temperature even after cutting, which means that the temperature is independent of mass. If I am going to cut this second body into three pieces of 10 kg, 10 kg and 5 kg each, all the three pieces will have the same temperature of 800 degrees Celsius, which means that the temperature is independent of mass of the system. So it is an intensive property. Now we are going to explain extensive property. Extensive properties values are dependent upon the mass of the system, which means that if you are taking some amount of mass from the system, the property value will change. For example, volume and energy. Okay, consider the same metallic body which is having a mass of 50 kg. So its volume is 6 meter cube. Let us assume it as 6 meter cube. Now I am cut it into two pieces and taking it away. So what will happen? The mass will be 25 kg and 25 kg each, and the volume will also become half and half, means each will have volume of 3 meter cube each. So when we are taking some amount of mass from the system, so that volume of the system decreases, which means that volume property is dependent upon the mass. Then again, if you are cutting the right cube into three pieces of mass 10 kg, 10 kg and 5 kg each, each will have different volume. That is, the volume is depending upon the mass of the system. That is an extensive property. So in this lecture we covered the concept of properties and what is meant by property and what is the state of a system. And again we classified the properties into two: intensive properties and extensive property. So this is the end of this lecture. In the next lecture we will be explaining the thermodynamic process and cycles. So you can subscribe for latest videos. Thank you.
So, okay, students. So here you can see two types of thermal property is extensive and extensive. Intensive and extensive. So what is the intensive property? It is not undependent on the mass. Means mass is independent. Okay. So what is the meaning of that? The meaning of that, the mass is independent. Means like there is an example, a bar of 800 degree temperature, and we divide that bar into two parts. So both parts having the same temperature, both parts having the same temperature, like 800 and 800. What is the extension? Extension means the property which is dependent on the mass. Okay, if the mass is changed, then property value is changed. Like a same example, bar having the how much 50 kg is there, and we divide into two parts, 25 kg to 25 kg. So if the volume of if the volume of 50 kg mass is the 6 meter cube, then if we divide into 25 kg to 25 kg, so the volume is also divided into 3 meter cube to 3 meter cube. Okay, so this property is depend on the mass. Okay, so that is called the extensive property. So now I will share my lecture notes PPT. Just wait 1 minute. Okay, so now you are able to see my PPT. Okay, so this is the we can say that this is the first lecture. This is too long. I totally start our session now. That is the thermodynamics property. Okay, the first unit and first chapter of the syllabus of the subject. Okay, so this is the basic mechanical engineering, and we are going to study the thermal properties. Okay, so what are these thermal properties? You can see thermal properties of a system. Okay, temperature, pressure, volume and specific volume, mass and weight, density, specific gravity, humidity, absolute and relative humidity. So there is two parts of the humidity in absolute and relative humidity. And now these properties, intensive and extensive properties, you just go through from the video. Okay, this video I will show you. In that you can see what is the intensive property and what is the extensive property. Okay, so let us start. Before going to start, so what is the thermodynamic system? First, we can understand what is thermodynamic system because we are going to study the property of the thermodynamic system. So first, we know what is thermodynamic system. So what is the thermodynamic system? Thermodynamic system is whatever we want to study subject of the analysis. Okay, so this is very important. Okay, first we going to study the property of the system, but what is the system we understand first. Okay, so there is a system, closed system and open system. closed system and controlled volume. So here, what is the closed system? Closed system always contain the same amount of the matter, like a engine, our 16-cylinder engine. So what happens? The gas is here, gas is compressed, gas is extended. Gas is compressed, gas is extended. So what is the same amount of volume is remains constant. So in the closed system, we can say that the volume is constant. There is no change in the volume. Okay. Control was see here. Mass may be cross the boundary is the control volume. See. So these are the type of system. Now we start our the first property, that is the temperature. Okay. So what is the definition of the temperature? The degree of hotness, the degree of hotness or coldness of body. Sorry, the degree of hotness or coldness of a body or environment corresponding to its molecular activity. Okay, so what happened? The molecular, what do you mean by the molecular activity? The meaning of molecular activity, the movement of molecules in the body or environment. Okay. If the moment of the molecule is very high, then it means the temperature is increasing. If the moment of body is decreasing, it means the temperature is down. Like when we make a cold of anybody, then what happens? The body start the shrinking due to the cold. And when we increase the temperature of anybody, the body is extended. Body is extended. Okay. So it is a measure of the average heat or thermal energy of the particles in a substance. Okay, what is the meaning of that? It is a measure of average heat or thermal energy of the particles in a substance. Okay, so is a reverse. Substance is a closed vessel is also substance. Okay, so these are the substance. Let's share the screen again. Yes, I shared the wrong thing. Share, yeah, okay. So particles in the substance. Okay. So why the heat energy is involved? Okay. So when we provide the heat, we heat the something like heat is required for cooking the food. Heat is required for the body temperature. We maintain our body temperature. Okay, like our body temperature is between 22 to 28 degree temperature is our normal body temperature. If our body temperature below the 20 degree, then we feel cold. And if the body temperature is more than 30 degree temperature, then what is 27 degree temperature, then we feel hotness. Okay, our body is hot now. Okay, so the range with normal body temperature is 22 to 28. Okay, so if the temperature range is beyond the higher limit or lower limit, then we feel cold or hot environment. Okay, so temperature is a measure of what is how we can measure the temperature and why we going to measure the temperature. The total amount of thermal energy in an object. Okay, so we can measure the thermal energy which is available in a body. Okay, how much heat an object given up. Okay, how much is an object given up. Okay, so what is the meaning of that? Means if two bodies is there, one body is hot and one body is cold, then what is the meaning of that? The temperature of one body is high and the temperature of another body is low. So that is the cold and the temperature is high. So what is the process is that the process is that the process is that the temperature or energy always flow higher to lower, higher to lower. Okay, so if T1 is greater than T2, if the T1 and T2 two temperature is here and T1 temperature is greater than T2, then the temperature flow always T1 to T2 until T1 equal to T2, until T1 equal to T2. So I give an example for that. uh, uh, take some water and heat up them around some temperature, normal, warm, cool. Okay, and take a chilled water. Okay, a water which is around 50 degree, 55-degree temperature, and a cold water from the freezer, liquid position, and take a normal water. Take normal water. Three water is there. One is hot, cold, and normal water is there. Okay, and normal water is there. So what you can do? You dip your hand in the hot water, one hand in the hot water, and one hand in the cold water. Okay, for few seconds, like 30 seconds. Okay, one hand in the hot water and one hand in the cold water. Okay, so for the 30 seconds, and now put up your hand and both hands and pour in the normal water. Pour in the normal water. Then what happens? You what one hand which is come from the hot water, the normal water feel cold water for that hand. And one hand which is come out from the cold water, the normal water feel hot water for that hand. Okay. Same body hand in the different feeling. Same water is there, but one hand is feel like this is the hot water, and one hand is feel like that is the cold water because the temperature different. Okay. Then our body release the temperature, pass the temperature. Then our body feel cold. Okay. Then our body is accept the heat from the environment. Then we feel hot. Okay, like summer days. Summer days was happen the outer temperature of our body is more than our body temperature. Okay, so we feel hotness. Okay, and in the cold season, in the winter season, what happens? Our body temperature is more than outer temperature. So our body transfer the temperature to the environment. So we feel cold that time. Okay, this is the phenomena of the temperature difference and flow of the temperature. Okay, how fast molecules in an object are moving. Okay, if the temperature is high, the movement of a molecule is very fast. Okay, if the temperature is low, the molecule movement is slow. And if what happens if the temperature is very high, like minus 10, minus 20, minus 30 degrees. So the movement of molecule is negligible. They can't move due to the very low temperature. Okay. So see here one more definition is there. It is a measure of average energy of motion. Okay, it is a measure of average energy. It is the measure of average energy of the motion. Okay, next are kinetic energy of the particle in the matter. Okay, what happens? It is the measure of average energy. Okay, what is the average energy? Temperature energy we can calculate. Or kinetic energy of the particles. Whatever the molecules or particles presented here, how they mean kinetic energy. What is the meaning of kinetic energy? Kinetic energy is the motion, the energy produced due to the motion. That is the kinetic energy. Okay. So whatever the kinetic energy of the molecule, that is the measurement of the temperature. You see here, E equal to 1 by 2 mv square. This is the formula for the kinetic energy of any body. Where m is the mass of the body, m is the mass of the body, and v is the velocity of the body. Okay. So E equal to kinetic energy equal to 1 by 2 mv square, where small m is the mass of the body and v is the velocity of the body. Okay, how do we measure the temperature? How? Thermometer. Thermometer is there. Thermometer is there when we feel fever and go to the doctor. Then what happens? Doctor measure our temperature through the thermometer. Through the thermometer, they put the thermometer in our mouth, or we can also take the thermometer in our hand to measure our body temperature. Okay. Next thing, instrument or device. Or some instrument is there, like there is in this time COVID situation. What happened? This is not possible. Anyone avoid to touch anybody. Anyone avoid to touch the body. Then the temperature gun is there. The thermal gun is there. So it is don't touch the body, but it is the uh, some rays is there which is contact to your body and measure your temperature. Okay, thermal gun also is there. Okay, which is so it is the instrument or a device. Okay, for measuring the temperature.